So the way VDR works is by tapping into a set of powerful tech building blocks which have been years in the making on Christie CinemaLife real laser projectors. So CinemaLife Plus is our Series 4 series of electronics, which handles the frame-by-frame image analysis and real-time algorithm processing. Then there's our LOS V2 laser systems. LOS stands for Laser in Optical System, which enables fast, precise modulation down to each individual frame at 24 frames per second. Paired with that are high-speed laser drivers that offer microsecond level control. So as you see in this diagram or workflow here, we take the incoming video signal, we analyze it in real time to pick out the brightest feature in the image, then we only generate the laser light that's needed to cover that brightest feature as peak luminance, and the original image highlights are maintained with deeper blacks. So we generate light only when needed. We're looking to launch VDR in 2 different operating modes. It is still in development today, but we're looking to launch it in a standard and a performance mode. In standard mode, VDR will play standard 14-foot Lambert, 48 nit content, the standard DCI grade that's put out today, but it'll double your sequential contrast on screen. So bringing you from about 2,000 to 1 to approximately 5,000 to 1, while also cutting energy use significantly and extending laser life. Should be a real ROI right out of the gate, and it'll work across all screens, big and small, with standard content that's delivered today. Performance mode will take things up a notch. So this is a technology that allows playing content up to 300 nits outside of proprietary formats like Dolby Vision, and pushing it up to 60,000 to 1 contrast. You'll see this in action today. It's impressive, but there's very little native 300 nit content out there. And honestly, that level of brightness can be a bit much in a cinema setting. It can be a bit jarring. What's exciting is the flexibility of our VDR technology. So this can support anything, and something like 150 nits or any kind of new grade that comes out for HDR presentation could be supported by this technology. The key takeaway is that VDR works with our existing content and our existing projectors, and there's no special mastering or special hardware required. So now onto the fun part of the demo. We're going to kick things off by demonstrating performance mode using content that's been mastered at 300 nit peak brightness. It's all PQ encoded, and we will start with some color swatches beginning at 300 nits. So in that part of the demo, the peak brightness will be at 300 nits, and then we'll drop it down in 4 levels to the video black of the projector to show the difference in the side-by-side configuration that VDR makes. We'll then show some STEM 2 content. STEM stands for Standard Evaluation Material, and STEM 2 is designed to test HDR display equipment. And then we'll go into Freak Fusion Cabaret, which was a DCP provided to us by Colorfront, which again is at 300 nits peak brightness and is HDR graded. The hardware you'll see this on is 2 identical CP4435 RGB projectors. What we've done is split the screen, so 2 projectors showing on the same screen. It'll be half an image from each projector. And then we've got optical blinders in place, so we're not overlapping the off-state light from one projector onto the other. And you can see that back up behind you on the platform. And what this does is it'll show the right side of the screen with half of one projector with VDR enabled, and the left half with VDR disabled on a separate projector. That content is running off of Christie IMBS4s, and it's being shown on a RealD 2.0 Ultimate screen. So let's get to the content, and here you go. So the first thing I'll point out is these color swatches are at 300 nits. They've been calibrated identically. You should really see an identical image from both projectors, or an identical half image, I'll say, from both projectors at this point. And then we'll drop the brightness down to 150 nits. And you can see, you can start to see a difference in the contrast level. And that's because we're not generating on the right as much laser power as we are on the left. And so all that off-state light that's bouncing around in the system isn't being generated, not killing your contrast with VDR. I'll draw your attention to these power bars on the sides of the screen. You'll see this one on the left has a red bar at the top, which represents the laser power. Green bar at the bottom represents the video signal, or the peak luminance in the image. So as we continue to drop, you'll see those bars get further and further away. On the right side, they should stay together. And when they overlap, it provides a little white or gray line as opposed to the separate green and red lines. And now we've dropped to video black. The projector on the right is still turned on. It is still lasers on, but they're just on at a much lower level than the one on the left. And so you can see very apparently here what kills contrast in a cinema environment is having to maintain a very high light source output, whether it be a xenon lamp or an RGB laser pack. So now we'll step the brightness back up, 75 nits, and then to 150 nits, and then to the full 300 nits. And as we get into the video content, it can be a little bit distracting, but continue to pay a bit of attention to those bars on the side, and you'll see the difference between VDR off on the left and VDR being enabled on the right, in that the laser power level will always be pegged at 100% on the left side, and it'll be dynamic on the right as that video signal is changing.
Let's try here. I can't see a thing. Be patient. Doctor? Get set up. Hand me the spectrograph. This is it. Give me the extractor. Gavin, extractor.
All right, what you just saw was content mastered at 300 nits, with black levels reaching as low as 0.005 nits, that's 5 millinits, delivering an effective sequential contrast ratio of up to 60,000 to 1. I hope that difference was clear to everybody in the audience, and big thanks to Colorfront for providing the content for that portion of the demo. I should mention that this presentation portion is not being shown on a VDR-enabled projector. It is being shown on our new prototype RGB-H projector, which is a 20,000 lumen hybrid light source. And that projector we're looking to launch in a 4K compact 0.98-inch DMD size, roughly at the end of this calendar year. So next we'll move on to a demo of the standard mode that I had mentioned. You're about to see two Hollywood trailers played at 14-foot, or graded to 14-foot Lamberts, or 48 nits. Unfortunately, due to constraints in this room, screen size and gain, and the size of the projectors we're working with, this is a 35,000 lumen projector, we're not able to get it down to 14-foot Lamberts, but we have maintained a contrast ratio of 5,000 to 1, as was intended as the maximum for this grade. So it'll be showing a little bit hot, and also in evaluating the contrast, note that we've got a white ceiling in this room, so it's not really an optimal viewing angle for judging that subtle a change in contrast level versus the moving to 60,000 to 1 that you saw previously. However, first up is the Amateur from 20th Century Studios, followed by Thunderbolts from Marvel Studios, and these will play full screen on a single CP4435 RGB projector with that same Christie INBS4, so we preserve the original playback intent. Standard mode VDR will be enabled throughout the content. We'll actually switch it on and off. So what you'll notice is, again, that power bar at the side, when the red bar, which represents the laser power, is pegged at the top and it's not moving along with the video level, that means that the VDR has been turned off. When it's turned on, those two bars will move together. And I'll point that out during the content as it's being turned on and off.
You ever wonder what they do with all the stuff you dig up for them?
That's not my job.
No, but you never wonder?
No, it's the CIA. I gotta trust that thing.
So we've started this demo with the VDR feature turned off, and you'll see that the laser power is pegged at 100%, and the video signal is represented by the green bar, moves up and down dynamically.
I think you need to see this.
And now we've turned VDR standard mode on, and so they are locked together. The video level and the laser power are matching. And again, it is difficult to notice the sequential increase in that contrast, but we'll get into some other benefits at the end of the demo.
We do. Let us handle this.
I want mission-specific training, cash, and a new identity.
Have you lost your mind?
I want to find and kill the people who murdered my wife.
I don't think you could beat a 90-year-old nun in an arm wrestling match.
I want to face my wife's killers, look them in the eyes, and balance the scales.
Take it. Take it! Aye. Point it at my chest! Do it now! Put your finger on the trigger. You can't do what I do no matter how much I train you. You're just not a killer, Charlie.
You're just a nerdy fellow who works on computers.
What you doing? Just gonna kill you. Do you ever account for the things I'm good at? You held a gun to my wife's head. This is a remote that controls a device that's been decompressing the glass beneath you. You have the wrong person. No, I have exactly the right person.
We got a ping in.
And now we've turned the VDR feature off again, so you'll see the laser power is once again pegged at 100%.
Judge this individual. This ends here.
You recognize her? If you jump really fast, you might survive the blast.
Wait!
Click leave on porch.
Alexi, it's me. Open up.
Is that not?
you can see again, VDR has been disabled, and we will re-enable it shortly.
Was on an important call, highly classified.
You feel fulfilled?
Oh, yeah. Yeah, so full. So filled. But why do you ask this? What brings you here?
And now you can see the VDR standard mode is running as the laser power is locked to the video level.
In emptiness. I'm just drifting. And I don't have purpose. I thought throwing myself into work was the answer.
Hi, I'm Bob.
Who sent you, Bob?
Nobody. You were all sent?
What the hell? We're brought up with this belief that there are good guys and there are bad guys.
What's the plan?
This could get messy. But eventually, you come to realize that there are bad guys and there are worse guys and nothing else. Look at you. So adorable.
She's bulletproof. What happened to bulletproof? It's bulletproof-ish.
Is that Bucky?
That's not good.
All right, wrapping up the demo, I want to highlight the kind of power savings you can expect with VDR in both of these modes. So these numbers on the screen here, the 32% reduced laser power consumption over the course of the whole demo, that is a real number as measured with a current clamp on a projector in our lab in Kitchener. And that was split between the HDR content, which was about 42% power reduction, and the SDR content, which was about 16% reduction. The HDR content, of course, was driving a much higher power level overall, but we were able to reduce the laser power down to about 8% for a lot of the content in darker scenes. The SDR trailers are not necessarily the best for evaluation, as they tend to be pegged at 11, so to speak, but at the same time we still achieved a 16% power savings over the course of that demo, and both of these numbers are impressive in terms of the laser power savings and electricity savings that you realize, but also the impact that they have on laser life extension. So lasers don't really like to be driven at 100% all the time, and so we normally recommend that you size your projector at about 80% of, with 20% headroom, which means it's at 80% power level when you're operating at 14-foot Lamberts. And the laser life extension you can get with even a 16% reduction in average power level is about 50%. Up to 70% with the 30% or higher savings that you could get on the HDR content. Now, of course, with the HDR performance mode, you'd be offsetting that against the use of an ultra-high contrast lens so that you can run your system at 100% as a starting point and then get it down to a more reasonable power level, on average using the VDR feature in performance mode. In standard mode, you'll be sizing your system likely at about 80% like usual and run at a constant 80% power level for really the life of the projector. Normally we say that would last about 50,000 hours before the brightness started to decline from the laser devices when run at 80%. With VDR enabled, because you've brought it down from 80% to now an average of about 64% with that 16% reduction, you'll extend that out to 75,000 hours which on a heavy duty cycle cinema would represent about 15 years of operation. So if you're operating 14 hours a day, that's 75,000 hours, represents 15 years. So really the lasers should put out constant power for the life of the equipment. So as a final wrap up, VDR maximizes the value of your CineLife Plus real laser investment by delivering stunning visual quality, improved operational efficiency, better laser lifetime, and flexibility to be used in any auditorium. And we're looking to launch the standard mode commercially in approximately 8 months, at the end of 2025. So it should be available soon. Thank you, and enjoy the last few minutes of CinemaCon.